Hey guys, today we're going to move into section 4.9, which is actually the last section of this chapter for us. And this is on isosceles and equilateral triangles. Now, we did already kind of dabble with isosceles and equilaterals, so to be honest, a lot of this might seem like review. So remember isosceles? Isosceles means that there are two sides congruent, so notice those tick marks. TR is congruent to RS. So yes, this is an isosceles triangle. Now, the part that we didn't talk about is, this is called the isosceles triangle theorem. It says basically if two sides are congruent, then two angles should be congruent as well. How do you know which two angles? Well, they should be the ones that are across from the sides. So here, TR is across from S, so angle S. And then RS is across from T, so angle T and angle S should be the same. And that's what the isosceles triangles theorem is telling you. Now, the converse, remember converse just means read it in reverse. So the original said if the sides are equal, then the angles are equal. Well, this one, if the angles are equal, then the sides are equal. So it's an isosceles triangle. So here, this angle across from it, this side. Here's an angle across from it. Those sides should be equal. So since those angles are equal, the sides across from them should be equal. And that's all this is saying. Same concept with equilateral. Oh, we're going to do that later. So we'll stick to isosceles for right now. So let's look in here. So we see here that it's isosceles because we have two congruent sides. So again, across from them, we know angle C should be the same as angle A. Well, how many degrees do we have in a triangle? We have 180. We're going to subtract out the 78 we already used, and we're left with 102 degrees. Now, what do we do with that? Right? What do we do with that? Well, you know, you have two angles that you need to split it between. You know they're equal, so we can take that and just cut it in half, which means this one's going to get 51 degrees, and this one's going to get 51 degrees. So what's the measure of angle C? 51 degrees. Let's look at the next one. Same concept. These two sides are equal, travel across. These two angles should be equal, right? Travel across. So we have 180 degrees, subtract out the 86 that we already used, and we get 94 degrees. And then remember, you want to split it between two equal angles. So we're going to split it between two equal angles, and we're going to get that each one is 47 degrees. So angle P is 47 degrees, and angle Q is 47 degrees. And that's what they asked for. Now, of course, they do get a little more complicated. So again, you see those sides are equal. So the angles across from them, so angle H, should be equal to angle J. So the sides across from them should be equal. So you know 6x plus 18 has to equal 8x. I'm going to go ahead and subtract 6x from both sides. We get 18 equals 2x. And divide both sides by 2, and you get x is 9. Now be careful, they don't ask for x, they ask for angle H. So we've got to plug in 8 times 9 is 72 degrees. So be careful, make sure you answer the questions. Next one, again, isosceles, two sides are congruent, so travel across. This angle should be congruent to this angle. So 2x has to equal x plus 30. If we subtract 1x from both sides, we get x equals 30. And from here, we look at the question. Find the measure of angle M. So angle M is x plus 30, so 30 plus 30 gets me 60 degrees. Now, you might not see it right away, but look here, 2 times 30 is 60. So we have 60, 60, that one's going to be 60 as well to make 180. So even though this is marked as isosceles, if you actually found all those angles, you would find out that it was equilateral. All the sides are equal and all the angles are equal. Which brings us to our next part, equilateral. So again, we kind of talked about how these go hand in hand. If you tell me that all the sides are equal, then you know all the angles are equal. And if you tell me all the angles are equal, then you know all the sides are equal. And that's what these two corollaries are saying. They're telling me so in this picture, we know it's equiangular. If all these angles are equal, we know all the sides are equal as well. So if it's equiangular, then it's also equilateral, and it goes back and forth. One of the biggest things that you should take away from equilateral triangles is you've got three angles that are all the same. So you have 180 degrees split between three angles. Each one's getting 60. And a lot of people forget that when they tell you that it's an equilateral or equiangular triangle, you know every angle is 60. So let's look at some examples. So again, I see this side, this side, this side. All those sides are congruent, so we know all these angles are congruent, which means you know every angle is 60. So 5n has to equal 60. Divide both sides by 5, and you get 12. And they asked for n, so we're done. Same concept here. All the sides are equal, which means all my angles are equal, which means every angle has to be 60. So 2x minus 6 has to equal 60. Add 6 to both sides, and then divide both sides by 2. So you get x equals 33. And that's what they asked for, so we're done. Now be careful here. Now we're talking about sides. So here they told me it was equiangular. We know it's equilateral as well. So you know all the sides are equal. Well, if the sides are equal, then set them equal. 5r plus 8 has to equal 9r. We're going to subtract 5r from both sides and divide both sides by 4. Now, they did ask me for VT, but they could have asked me for anything. They're all the same. All right, 9 times 2, 18. Sorry. 5 times 2 is 10, plus 8 is 18. And even though there's nothing on SV, you know it's going to be 18 as well. So all the side lengths are 18. It really didn't matter where you plugged it in. Remember, this is equilateral and equiangular. Everything's equal. Same concept here. We know all the sides are equal, right? If it's equiangular, it's also equilateral. If all the angles are equal, all the sides are equal. So you know y plus 10 has to equal 4y plus 1. All right, we're going to subtract y from both sides. So we've got 10. 4y minus 1y is 3y plus 1. We're going to subtract 1 from both sides. We get 3y equals 9. And we're going to divide both sides by 3, and we get y equals 3. Again, we're going to read. And sometimes they'll try and throw you off, and they'll ask you for, like, ln, where there's nothing there. And people freak out. Understand. Look here. 3 plus 10 is 13. This side's 13. 4 times 3 is 12, plus 1 is 13. This side's 13. This side's 13. Even though there's nothing there, you know all the sides are 13 because it was equilateral. So it really doesn't matter where you plug those in. Just make sure that you understand all the sides are equal. All right, so those are your notes. And then you have a worksheet to do. It's basically the same concept. Now here you've got to follow some stuff going on here, so mark this picture up. But once you get into these, the one thing I want to point out is definitely be aware of vertical angles, so you know that angles are equal and stuff like that. But other than that, know what pieces are equal, know what's isosceles, what's scaling, all that good stuff. All right. So finish this up, and this is what you'll upload to Focus when you're done. All right, bye guys.